So today we're going to talk more about limits. We are going to continue what we had last time. So we're done with those limits that are in the form of mm, quotients, the functions, mm, where you encounter indeterminate form 0 over 0. And also, we had limits involving radicals in the numerator and denominator, but still producing a form of limit that is 0 over 0. And another, we had limits involving absolute values, and then limits involving greatest integer function. Okay, so we'll continue on that. So again, number one, we're asked to evaluate limit as x approaches, let's say, 2 of greatest integer of 2x plus 1. Okay, so how to evaluate a limit like this? So to be able to evaluate a limit like this, so you're going to first get the limit from the left and limit from the right of 2, but close to 2. Okay, so that we will able to get rid of the what of this greatest integer symbol. So first, let's take limit from the left of 2. Limit as x approaches 2 from the left. So we have greatest integer of 2x plus 1. Now, if x is close to 2, but from the left, say 2 point what? What's my calculator? 1 point, 1 point something, well, let's say 1.9. 2 times 1.9 plus 1. So this is something 4.8, no? So it means if x is close to 2 but to the left, then we have x is element of what? If x is an element of between sorry, if 2x, let's say, if 2x plus 1 is an element between 4 and 5, but less than 5, then the value of this is 4. Okay, so as you see, if I'm going to assign a value to x that is close to 2 but to the left, which is 1.9, 2 times 1.9, then plus 1, I get something 4.8. So it means close to 2 from the left, 2x plus 1 is always between 4 to what? 4 to 5, right? So if it is between 4 to 5, it means less than 5 but greater than 4 or equal to 4, it is simply 4. So I can simply write it limit as x approaches 2 from the left. So this is simply 4. And what is the limit of 4? The limit of a constant 4 is equal to 4. So if x is close to 2 from the left, 2x plus 1 is always or is simply 4. And the limit of a constant is 4. Okay? So what about from the right? If we will able to get also 4 from the right, then we say that the limit of this exists and is equal to 4. Let's see. Limit of greatest integer of 2x plus 1, and then as x approaches 2 from the right. So if x is closer to 2 but to the right of 2, so we say that 2x plus 1 is what? So let's say 2.1. So times 2 plus 1, we have something 5 no, greater than 5. So it means it is between 5 to 6, but less than 6. So the greatest integer of a number that is from 5 to less than 6 is always what? Is always 5. Therefore, we can say that this greatest integer of 2x plus 1, if x is close to 2 from the right, so is simply equal to 5. So the limit of that is equal to 5. Therefore, since although both from the left and the right limits exist but they are not equal, so we can conclude that the limit as x approaches 2 of the greatest integer of 2x plus 1 is what? Is not existing, or is non-existent. So therefore, does not exist or non-existent. Non-existent. Okay? Or no limit. It has no limit. So, again, the limit of the greatest integer of 2x plus 1 as x approaches 2 does not exist. Okay, number 2. What about if we have a limit that takes this form? So let's say I have limit as x approaches two of this quotient. So the numerator is greatest integer of x plus greatest integer of 2 minus x plus 2. Then we have in the new denominator greatest integer of x plus x. So let's see what the limit of the denominator is and also what the limit of the numerator is. Since this is a quotient, you can just simply substitute, okay? So aside from that, because greatest integer is involved, and we know that greatest integer is what? Is constant in a particular interval. So let's see how we can get rid of the greatest integer symbol, since we know what x is, no? We know that x is close to 2 from the left and from the right. So let's see first from the left, because this involves greatest integer. If you have greatest integer, or you always check limit from the left and limit from the right. Okay? So we have from the left limit as x approaches 2 from the left of this quotient. So let us just copy that. So what we are assigning to x is what? we are assigning a number that is close to 2 but to the left. Let's say what? So say x is equal to, let's say, 1.9. Okay? Let's try to evaluate the greatest integer. So we have 1.9. So what is the greatest integer of 1.9? Guys? So what is the greatest integer of 1.9? So this is going to be what? This is 1, no? This is 1. Okay? So we now have, so we can now remove limit as x approaches 2 from the left. So the denominator, so this is 1. And then plus what? Ito, this is still x. So we cannot do something about that. But what about in the numerator? So the first term is also 1, no? 1.9, greatest integer is 1. Plus 2 minus 1.9. So 0.1. So that is 0. If x is close to 2, but between, let's say, x is between 1 but less than 2, from 1 to less than 2, so this is always what? 0, no? 2 minus x, greatest integer of that is 0. Then plus, this is 2, no? Okay? Yeah. So let's fix this. Here. Okay? Yeah. So this is the quotient obtained, no? Equivalent to the original equation, but not actually equal, but just equivalent if your x is close to 2 from the left. So this is equal to 2. This is equal to what? Limit. Let's simplify. X, as x approaches 2 from the left. So the numerator is 3. The denominator is what? 1 plus x. So this is not indeterminate, right? So we can now apply substitution technique. So and this gives us 3 over 1 plus 2. And that is equal to 1. Okay, guys? Did you get that? So the limit of this quotient as x approaches 2 from the left is equal to 1. What about from the right? So limit. So as x approaches 2, but this time from the right. Okay? So this is the quotient. And then let's simplify this greatest integer terms. So as x, when x is close to 2 from the right. So say x is what? Say x is equal to 2.1. If x is 2.1, so 2 to less than 3, so the value of this is what? The first term. The first term is simply 2, no? So limit as x approaches 2 from the right. So the first term is 2. So 2 point something, 2.1 for instance, that is 2. So when x is between 2 to less than 3, from 2 to less than 3, so this is always what? 2. then plus, what about 2 minus x, greatest integer of that? So 2 minus 2.1, so that is negative 0.1. So therefore, if I remove the greatest integer symbol, this is simply negative what? Negative 1, right? Am I right, guys?
Yes, sir.
Okay? Yan. So you have negative 1. If your x is close to 2, that's say 2.1, from the right of 2, so 2 minus x is always negative 1. Okay? Yan. Of course, that is close, ha? You don't go to the next interval, which is another possible constant value of this greatest integer. Remember, this is always an integer at different integers at different intervals. Then, plus 2. So, because that is already fixed as 2, all over, so we know that this is 2, no? If x is to the right of 2 but less than 3, that is always 2. Then plus x. So I can now simplify this. 4 plus negative 1 is 3 all over 2 plus x, right? So, and what's the limit of this? Guys?
Sir, hindi po ba zero yung negative 1 dapat?
0? Why is it 0? Why do you think it is 0? Who knows? You're right and I'm wrong.
Kasi sir, negative 0.1 po siya.
Negative?
0.1 as 0.
Negative 0.1? Do you mean 2 minus x?
Yes, sir.
Okay. So, if this is, let's say, 0, this is negative 1, negative 0.1 is somewhere here. Remember, greatest integer, you're pulling it to the left. Where is the left of negative 0.1? Where is to the left of negative 0.1?
Okay, sir.
Negative 1. You always pull it down. You are confused because of the sign, no? If you have 0.1, it is 0. Okay? Because 0.1 is somewhere here. You pull it down or you pull it to the left, so it is 0. Remember, greatest integer is pulling down to the what? To the closest integer that is less than or equal to the given number. Let's say 2.1. So you pull it down, it is 2. Because the greatest integer that is less than or equal to 2.1 is 2. Okay? If it is ceiling function, you pull it up or you push it to the right. Is that clear, guys? Guys, so better if you can't do it mentally, you draw a number line so that you know where to pull it down. Okay? And this is now equal to what? This is equal to 3 over, we can now apply substitution technique here because this is no longer indeterminate form. So it's not it's not an indeterminate form. So it is now 3 over 4, okay? So is 3 over 4 equal to 1? Of course not, no? Therefore, the limit of the original given does not exist, okay? Again, since the limit from the left is 1, limit from the right, 3/4, although they both exist but not equal, therefore we conclude that this limit of this quotient as x approaches 2 does not exist or it is a non-existent, no? So, we can now conclude. Let's copy this. So that's how to evaluate if you have a limit like that, okay? You can't apply substitution technique immediately because the behavior from the left and from the right are not the same, no? So therefore, we conclude that this limit does not exist, no? There are books, especially in Europe, books in Europe, they normally use non-existent instead of does not exist. Non-existent. Do you have any question here, guys? Guys,
None, sir.
no more question with that? Okay. So let's see. Let's say I have this limit. Number 3. We have limit as x approaches -2 of greatest integer of x plus 3 plus absolute value of x minus 2 plus square root of, this is something different, no? Because it is a reunion of different types of functions. So we have a greatest integer function, absolute value function, square root function, and a monomial function, no, which is actually under a polynomial function, linear function. Then all over the denominator is square root of 2 minus x and then x times absolute value of x plus 1 times the absolute value of x plus 1 then minus greatest integer of x plus 3 then minus 4. Okay? Since there is a greatest integer again, so we have to make use of limit from the left and limit from the right. We have to get that. But let's say the given is already approaching limit from the right. Let's say limit from the right. Okay? You can proceed immediately because we don't need limit from the left, no? So we are just after limit from the right. So what number are we going to try, guys? Say what? Say, what do you think? X is equal to? To the left of negative, to the right of -2, guys. 1 negative what? Negative 1.9 or 1.09, 1.8. But don't go to the next integer, ha? Do not assign it because otherwise you will able to jump to the next interval, which is a different behavior. Okay? So be sure really close to -2, no? Because if you will able to assign a number that is, it's like in a next barangay, so you will have another behavior. Okay? So my problem is I will forget this, no? So let's copy this. This given. And copy. And let's put it somewhere there. Yeah. Okay? So that is equal to, so limit is equal to what? This limit. So because we can proceed immediately now. So we have limit as x approaches -2 from the right. What about the first term in the numerator, guys? What do you think? So negative 1.9. So be ready with your calculator. What we are going to try, negative 1.9 plus 3, no? So remember ha, if you can't imagine the value, this is negative, this is 2, okay? So to the right niya is, this is negative 1. So negative 1.9 is somewhere here, negative 1.9, okay? Yan. So this is negative 1.9 plus 3, that is 1.1, right? So again, negative 1.9 plus 3 is 1.1. So an example of a number that is in the interval close to on the interval, and it is close to negative 2 from the right. So we have, so ang magiging value is 1.1. So that is 1, no? For this. Okay? So, and then, plus, how do we remove absolute value? Let's remove that. So that in case you will have problem later, at least no more absolute value. So, if you have absolute value, to the right of what? To the right ng negative 2. So, this is negative 2 minus 2. So, absolute value is what? Is 2 minus x, no? 2 minus x. Because we want it to be always positive. Yan. So, to the right of negative 2, 2 minus x is always positive. So, the absolute value of x minus 2 is 2 minus x. Okay? You can try a number close to negative 2, or actually you can have negative 2. Negative 2 minus 2. So, that is what? Negative 4. So, the absolute value is 4, meaning 2 minus x. So, plus square root of this one, we just copy because we can't simplify that anymore. And then, plus 3x together with 3x. What about this denominator? So, 2 square root of 2 minus x. And then plus x times what? Plus x times, what is the greatest, the absolute value of x plus 1? Negative 2 plus 1 is negative. So the absolute value is negative x minus 1. You negate the expression inside. So that negative 2, positive 2 minus 1. So 1, no? So, it agrees with the absolute value of x plus 1. What about this x plus 3? So, negative, we did that already, no? So, it's same with the first term in the numerator. So, this is plus what? Plus 1. And then, the last term minus 4. Okay? Let's simplify that. So, limit as x approaches negative 2 from the right of this, no? So, this is 1 plus 2, that is 3. Then, let's start with the radical, no? Is square root of x plus 3, and then followed by a term with variable, negative x plus 3x, that is 2x. Okay, guys? Check my operations ha. And then 1 plus 2, that is 3. Am I correct, guys? What about the denominator? The denominator is square root of 2 minus x. And then, this is negative x squared. Negative x squared. And then, minus x. And then the last term, minus 3. Okay? Let's see if the denominator will be 0 when x is negative 2, or let's take the limit, no? So, 2 minus negative 2. So, the limit of that is 4. Square root, so square root of 4 is 2, right? The limit of this as x approaches negative 2 from the right, so 2 minus negative 2, so that is 4, 2 minus 4, so 2 minus 4 plus 2, kasi minus negative 2, so plus 2 minus 3. So it is negative 3. It's not anymore 0, therefore we can proceed, no? Am I right, guys? So this is not 0, therefore I can now proceed. I apply now substitution technique, okay? I can now apply direct substitution, no? So again, the denominator, we have square root of 2 minus negative 2, so it is plus 2. And then minus negative 2, quantity squared, it is positive 4. Then it is now plus 2 minus 3. And in the numerator, we have square root of square root of what, guys? Square root of negative 2 plus 3. Negative 2 plus 3. Negative 2 plus 3. So it is approaching a number that is positive now. Because if, let's say, this is approaching 0, but through negative values, you cannot apply direct substitution to the radical. You have to be careful with the radical. If I have, let's say, x plus 2, and your x is, let's say, approaching 2, negative 2, from the right. If approaching 2 from the right, negative 2, so ano yung mga nasa right ng negative 2? So yun yung negative 1.9, no? Negative 1.9 plus 2. So this is approaching negative 2, magiging going to be 0 to, pero approaching what? 0 from the right. So it's all right. Pero kapag naman, let's say, negative 2 approaching from the left, ang left nito ay negative 2.1. Negative 2.1 plus 2, this is approaching 0 but from two negative values this time. So, square root of negative does not exist. No, it's not a real number. Therefore, you cannot apply direct substitution if that is the case. No? So, this is 2 times 2, negative 4. Okay? And then, plus 3. Am I right, guys? Guys? And that is now equal to what? What's now the limit, guys? Anyone who can simplify this? 1 plus negative 1 all over. This is 2. This is negative 4, negative 1, negative 5. Now, is that right, guys? And that is equal to, what is this equal to? 0, right? Am I correct, guys? Guys. Okay, so 0. Okay, so let us have the same problem. But this time, I want it from the right. Let's see how it behaves from the, from the left this time. The same problem. But this time, I want it from the left, no? So, our board is really like a blackboard, no? We are like in a classroom. So, this time from the left. So, say what? Say, x is, ano ang ating sample? X is negative 2.1, no?
2.1.
Okay, so that we can able to simplify this greatest integer. So, is equal to limit as x approaches negative 2 from the left, so x plus 3. What is that equal to? The greatest integer of that, if your x is close to negative 2 but from the left. So negative 2.1, our trial. Negative 2.1 plus 3. So that is 0.9. So going to be 0, no? So this is 0. Then plus, you have negative 2. Negative, still negative, no? So the absolute value of that is 2 minus x. So that this is always positive. Pag let's say positive ang loob, as is, x minus 2. Pag nag-negative ang loob, negate. Yun ang absolute value. We just copy the radical because there is no way to simplify that for any value, no? So we have 3x. What about in the denominator? So 2 minus x, then plus x. If you assign negative number here, negative 2, so plus 1, so going to be negative. So still x, that negate that, no? The absolute value is negative x minus 1. And we did this already, 0, then minus 4. Okay, guys? So this is now going to be limit, as x approaches negative 2 from the left. So when simplified, what's the simplified form, guys? So 0, 2 minus, I think, let's start with the radical, x plus 3, and then negative x plus 3x, that is positive 2x, and then plus 2. Okay? Yan. Plus 2. What about the denominator? Square root of 2 minus x, and then minus x squared, minus x, then minus 4. Okay? And this is equal to the denominator. If you have 2 minus negative positive 4, square root is 2. So 2 minus 4 plus 2 minus 4. Is it 0? No, not 0, no? Therefore, we can apply direct substitution rule to evaluate this limit. So this is square root of negative 2 plus 3. So going to be positive 1. This is negative 4. And then positive 2. What about this? The limit is square root of 2 minus negative 2. So going to be square root of 4. And which is equal to positive 2, no? Going to die na my computer. Okay. It's good that I was able to detect it. Minus 4, negative 2, because we square it, so minus 4 pa rin, no? Plus 2. And then, minus 4. Okay, guys? Guys. Not answer. So this is equal to what is now the answer in the numerator? 1 plus negative 2. Negative 1? Right? Is it negative 1 in the numerator? Negative 2 plus 1. In the denominator, ilan? 4 minus 8. 4 minus 8, negative 4. Is it 1/4, guys? Guys? 1/4? Okay now? So that's the limit. See? Very easy. As long as you know the rules and how to evaluate limits properly. Because if you do not know how to limit, you just substitute. No, limit is not just like substitution, ha? Although there are cases where you can apply substitution technique, direct substitution, but not all the time. Okay? So you have to see the functions involved first before proceeding immediately. Okay, guys? Okay, so let's have this. So let's say I have this piecewise function. What number is this supposed to be 4? This is 4, no? Let's say I have number 5. Limit as x approaches I don't know. As x approaches wait a minute. So we're given a function. Given f of x, and f of x happens to be a piecewise function. It is equal to 2x minus 5 if x is between negative 1 and positive 2. Including 2. It is negative 1 if x is between 2 and including 4. And then the last one, it is x squared minus 3 times x. So if x is between 4 and 6. Okay? And then we are asked of the following, letter A. What's the limit as x approaches negative 1 from the left of f of x? So this is equal to limit as x approaches negative 1 from the left. So what are those x that values that are to the left of negative 1? Okay, where? So what am I going to use? So I'm going to use 2x minus 5. But 2x minus 5 is defined between negative 1 and 2. So meaning, this is not defined when what? When x is to the left of negative 1, no? Okay? So this does not exist. Why is it that 2x minus 5 as x approaches negative 1 from the left does not exist? Because it's not in the domain, no? Since x less than negative 1 is not an element, no? Is not in the domain. In the domain of 2x minus 5 or of f of x, no? Okay? Or letter B. What about if you're asked limit as x approaches negative 1 from the right of f of x? Our f of x is given by what? By 2x minus 5 pa rin, no? Because it is covered, no? It is to the right of negative 1. So we use this. So since this is in the domain, and it is what? It is a polynomial, which is a linear function, we can apply direct substitution technique. 2 times negative 1 minus 5, and that is equal to, what's the answer, guys? Negative 7. Okay? Okay, letter C. What if you're asked of limit as x approaches, let's say, 0 of f of x? Where is 0? So 0 is between negative 1 and 2, no? So still, we're going to use what function, guys? 2x minus 5. Again, we can apply the substitution technique here. So 2 times 0 minus 5, and that is equal to 0. Letter D, limit as x approaches 2, no? Of f of x. Okay? Yan. Now, since this is piecewise, to solve for this, we have to look for the left and the right first. Limit kasi ang 2 nasa endpoints ng subintervals. Na? So, let's check first from the left. From the left of f of x is equal to what? From the left, it is equal to 2x minus 5. So that is 2 times 2 minus 5 negative 1. So that's the limit from the left. What about from the right? Remember the problem, huh? Guys? Do you still remember the problem? Negative 1 to 2, 2 to 4, 4 to 6, huh? And this. So what about limit? I am marking, I'm putting asterisk. Limit as x approaches 2 from the right this time of f of x. But from the right, f of x is defined by what function? A constant function, right? Which is negative 1. So the limit of this is negative 1. What's the limit in the previous one? Negative 1. Therefore, we can conclude that the limit as x approaches what? Of 2 from the right, as x approaches 2 of f of x is equal to what? Negative 1. Okay? Am I correct, guys? So, what's the limit of this? As x approaches 2? Since both from the left and from the right, we got negative 1. Therefore, so we say that the limit of f of x as x approaches 2 is negative 1. Still alive, guys? Number, letter D, letter F. What about limit as x approaches 4 of f of x? Again, solution for this, you have to, because that is piecewise, there's left and right, and that is an endpoint, unless it is in between, no? So, you can immediately get the limit. From the left first. From the left, how do we define f of x? Guys, what? Negative? So this is negative 1, the limit. What about if it is from the right? How do we define f of x? So that is, by the way, as long as you are not yet evaluating the limit, do not remove the word limit, because that is the signal that you are performing something. Because if you remove the operation, you can't perform anymore anything. Okay? So this is a polynomial function, quadratic function. We can apply substitution technique. 3 times 4, no? That is 16 minus 12. 4. Are they equal, guys? No, no? From the left, negative 1. From the right, positive 4. Okay? Are we right? X squared minus 3x the function? Okay. So, last one. What about limit as x approaches 6 from the left. If you have x approaches 6 from the x approaches 6 does not exist kasi wala na siyang right, no? Pero from the left, possible pa mag-exist. Yan. So this is equal to limit as x approaches 6 from the left. What are we going to use? X squared minus 3x. And we can apply substitution technique for this case. 6x squared minus 3 times 6. What is that? Equal to 36 minus 18. Is it 18? Okay, so that's the answer. Okay, guys? In F, what's the answer in F, by the way? We haven't answered letter F. Ay? Okay, let's move this down. And then yeah. So therefore, this limit does not exist. Or no limit. May mga book, no limit ang word na ginagamit. The mean does not exist. Pero ang modern term does not exist. O kaya non-existent. Okay, guys? What number was that? Number 5. So we're now on number 6. Number 6. Let us have this problem. This one is a different one. Is there a number C? Is there a number C such that limit such that the limit as x approaches 2 of 2x squared plus 3 minus 2c minus 3c. Sorry, wait a minute. Let me check the problem. Okay. So, is there a number c, 3 minus c times x? Is there a number c such that the limit of 2x squared plus 3 minus 2c multiplied to x, then minus 3c all over x minus 2 exists? So again, is there a number c such that this limit exists? Okay? If so, find the value of, if there is, meaning if there is c, find the value of c. Or what is that c? Find the value of c and the value of the limit. Any suggestion, guys? How are we going to solve this problem? Guys, how are we going to solve this problem? Is there a number c such that this limit exists? If so, what is that value of c? And also, what's the limit? Guys, any suggestion? Notice that the denominator is x minus 2 and it is 0 when x is 2. Therefore, it will not exist if the numerator will not have a factor x minus 2 that can be cancelled, no? So in order for this limit to exist, I must be able to cancel x minus 2. In other words, the numerator must have a factor x minus 2 also. So what is that C? So that this numerator is factorable into what? Into x minus 2 and whatever other factor, as long as it is not x minus, as long as there is x minus 2, no? So that we can cancel that x minus 2, okay? So, if you want your numerator to have x minus 2 as a factor, so it means, when equated to 0, so 2 is a root, no? Meaning, the numerator will be 0 when x equals 2. Okay? So we let, let's say f of x or g of x, let's say g of x to be equal to what? To be equal to the numerator or f of x. Let's say f of x. I want it to be f of x. Let f of x be equal to the numerator 2x squared plus 3 minus 2c x minus 3c. Okay? I want this to be what? To be 0. Meaning, if I evaluate this, I want it to be 0 when x is 2. So, yeah. We now have f of 2 must be equal to what? 0 na? Who is calling? Okay, so we now have wait a minute. So we have 2x squared. So that is now 2 times what? 2 times 2. So that is our x. Then we have 1t squared, no? Plus 3 minus 2c. But what is x, guys? So that is 2. And then minus 3c. And this must be equal to 0. And then solve for c. So this is 8 plus 6c minus 4c minus 3c is equal to 0. So getting what? So, sorry, this is not 6c, no? It is 6c, not 6c. So this is just 6. So 2 times 4, 8, plus 6 minus 4c minus 3c, giving negative 7c. Is that correct, guys? The right side, when this f plus 6 is transposed on the right, negative 14. So what is c? Positive 2. Okay? So it means there is c such that what? This limit will exist. And what's the value? C equals what? C is equal to 2, no? So the value of C is 2. Okay, so there is a number now. And what is the limit, no? Let's see what the limit is. So we now have limit. Still there, guys? Guys?
Yes, sir.
2 times x squared is still 2 times x squared. And 3 minus 2 times c. So this is 3 minus 4. What is 3 minus 4? That is negative. So negative x. 3 times 2, 6. So minus 6. So the numerator is this. And expected to be factorable into what? X minus 2 times other factor, no? So this is x minus 2. So factoring the numerator, of course we expect that one of the factors is x minus 2. So that's the reason we solve for c, so that we'll able to come up with x minus 2 as one of the factors of the numerator. So what is the other factor, guys? Okay, x plus what? Is it x plus 3? Ay, sorry. It is anong factor? Ha? 2x what? 2x plus what? Plus 3? Or ano, plus 3 na? Am I right? Yan. X minus 2, 2x plus 3. All over, what about the denominator? X minus 2. So I can now cancel this out. So getting limit as x approaches 2 of 2x plus 3. So the limit now is equal to 2 times 2 plus 3, which is equal to 5. So this is the limit that we are looking for. Okay? So again, there is a number c that will make the limit exist, no? So and then also the limit, we can find the limit, and the limit is equal to 5. Okay, do you have question, guys, here to that type of problem? So see, the problem is now getting exciting, no? So it's not really a direct evaluation of limit, but you have to think of it this time, analyze, no, what's being asked. Let's have another one. Number 7. So is there a number C? Again. And is there a number C such that the limit as x approaches negative 1 of x cubed plus a minus 2 x squared plus 3 minus 2a x plus 3a all over x squared minus 2x minus 3. Yan. Exist, okay? If so, find the value of, sorry, this is supposedly C, no? C minus 2, 2C, 3C. If so, find the values of C and the limit. No? Okay? I think now you have an idea of what to do here because of what we had in the previous example. Oh guys, what are we going to do, guys? So first, try to factor the denominator, no? And let's see what's the problem is, no? If there is really a problem. Who knows? Any C will work, no? So let's see. The denominator, let it be g of x. So the denominator is x squared minus 2x minus 3. And this is factorable into x plus 1 and x minus 3. Am I right, guys? Children. And this g of x approaches what? Approaches 0 as x approaches negative 1. Therefore, if we will not able to eliminate x plus 1 because it makes the denominator 0, no? As x approaches negative 1, the limit of that tends to be 0. Therefore, we need to eliminate that, no? If you can't eliminate this, so this will not exist, no? Okay? So what is that value C? So that the numerator will have also a factor of x plus 1. So that this expression that makes the numerator, the denominator 0, we will be able to eliminate. Okay? So, let f of x be equal to this x cubed plus c minus 2 multiplied to x squared plus 3 minus 2c multiplied to x plus 3c. So we want this to be what? To be equal to 0, no? When x is negative 1. Okay? So f of negative 2, f of negative 1. We want this to be 0, this expression. Yan. So that is equal to negative 1 quantity cube plus c minus 2 times negative 1 quantity squared plus 3 minus 2c times negative 1 plus 3c. And I want this to be equal to 0. Okay, guys? What is this equal to, guys? Guys, I am talking to people. Guys, guys, still alive? Guys, why not answering? Okay, let's simplify. What is that equal to, guys? 1 times, so negative 1, no? Negative 1. So this is negative 1. This is 1, no? Because it is squared. So it is plus C2, C minus 2. This is minus 3 plus 2C. And then, plus 3C. Would you please check my simplification, guys, of the left side? Okay? So it is equal to, is it equal to 6C, guys? Negative 5, negative 1, negative 6, transpose 6. So what is C? 1. Okay? So there is a C that will make the numerator 0, meaning to have a factor x plus 1, no? Yan. So there is a C. So, and we have found it. So, and then, what's the limit of this? Okay? So, limit as x approaches negative 1. So, we're going to have now C equals 1. So, that is now equal to x cubed. Let's evaluate this mentally. 1 minus 2, negative 1, so negative x squared. 3 minus 2 times 1, 3 minus 2, so 1. So times x, so plus x. 3 times 1, so that is plus 3. All over, we have already factored the denominator, no? So that is x plus 1, 2x minus, x plus 1, x minus 3. Right? Yeah. X plus 1, x minus 3. Okay now? What is the factored form of the numerator? Guys, limit as x approaches negative 1 of So, one of the factors, of course, x plus 1. So, how to get the other factor, guys? So, synthetic now, 1, negative 1, positive 1, and then positive 3. So, we're going to have a multiplier in negative 1. Okay? I can't make it straight. So, bring down 1, multiply to negative 1, add negative 2, multiply to negative 1, add, multiply to negative 1. So, this is now 0. So, the other factor, therefore, is x squared. Okay? X squared minus 2x plus 3. Okay, guys? All over x plus 1, x minus 3. From which I can now cancel this out, no? So, getting, we now have equal to this limit. Limit as x approaches negative 1 of what, guys? Guys, para naman mga deaf and mute kayo. So, we have x squared minus 2x plus 3 all over. Ayan. What's the limit? So, the numerator, negative 1, quantity squared, 1 na, no? Plus 2, plus 3 all over negative 1 minus 3. When simplified, 5 over negative 4 or 6? 6 negative. So 6 over negative 4. And that is equal to negative 3 over okay? That's the limit. Any question, guys? Guys, ano question? So, limit. What about this? Evaluate this limit. Evaluate. Yan. Evaluate limit as x approaches n approaches. As n approaches 0 of f of n minus f of 0 all over n. If f of x is equal to x, absolute value of x. Okay, guys? So here's the question. Evaluate this limit of f of n minus f of 0 all over n as n approaches 0 if f of x is equal to x times the absolute value of x. Okay, so first, let's determine the required function. No? So, f of x is equal to what, guys? Absolute value of x times x, no? Or x times absolute value of x, which means, if I solve for f of n, what is f of n? That is n, absolute value of n. Okay? What about f of 0? And f of 0 is what? 0 times 0. So, 0 na? Am I right, guys? Therefore, we have limit as n approaches 0. So, this is what? This is n absolute value of n minus 0. We don't write that anymore. Oh, I will write 0 all over 0. Sorry. Over, anong denominator? N. Right? So, we can simplify this. Limit as n approaches 0, I can cancel out n, right? Because the second term in the numerator is 0. So, n absolute value of n. Then, over n, no? I can cancel this. What is left now? We have limit of absolute value of n. And that is equal to, from the left, what is the absolute value? Going to be 0. From the right, what's the absolute value? Going to be 0, no? Whether true negative values, true positive values is still going to be 0. Okay, guys? So, that's the limit. You can do mentally the left and the right. From the left, although going through negative values, but still going to be 0. From the right, going to be true negative values, but still going to be 0. So, the limit is 0. Okay? Yes?
Bakit po hindi negative pag going from the left?
Which one? Alin ang di negative? Which one?
Coming from the left po.
Coming from the left. Absolute value to ha. Ang greatest integer lang, ang iba-iba. Sorry? Do you have concern? Iho? If you have absolute value, the absolute value of n is equal to n if n is positive or 0. Okay? But it is negative n if n is less than 0. Okay? But since we want it to be going to be 0, kahit pa negative n, positive n, is still going to be 0. Okay? Still have question, guys? Okay, guys. I can proceed now, ha? Guys. Okay. Number 9. Number 9. Limit, evaluate. evaluate the limit as x approaches as y approaches 1 of f of y minus f of 1 all over y minus 1 if f of x is equal to square root of x. Okay? So, doing the procedure that we had before, the procedures that we had, so, we are given f of x equals square root of x. Na? So, if you solve for f of y, it is simply what? It is simply square root of y, no? And what about f of 1? What is f of 1, guys? Square root ng 1. 1. Okay? So, we can now write the limit as limit of as y approaches 1 of what is the numerator now, guys? Square root of y, no? Minus f of 1 is 1. Okay? Over y minus 1. But the numerator and denominator both approach 0, no? Denominator approaches 0. The numerator approaches 0. Therefore, this takes the indeterminate form 0 over 0. Okay? So, we apply the technique that we had before. We rationalize the numerator by multiplying both the numerator and denominator by the conjugate of the numerator. Okay, guys? So, we multiply this by, what is our multiplier? Conjugate of the numerator is square root of y plus 1 all over square root of y plus 1. Okay? And this is now equal to the limit as y approaches 1 of the numerator. So that is y minus 1, no? Y minus 1. The denominator, y minus 1 multiplied by square root of y plus 1. I can now cancel this out. So, getting this limit of 1 over square root of y plus 1 as y approaches 1. Okay? So, this is now equal to 1 over square root of 1 plus 1. So, that is equal to 1 over 2. Question, guys? Guys? Any question? Okay? No question? So, okay now, guys. So, if you don't have any more questions, we're going to stop right here. So, and then you review what we had, all those that we discussed, and then I'm going to give you exercises about those limits without problems and with problems. So, especially problem on numerator and denominator, no? So, the numerator and denominator both tend to 0, no? So, you'll have 0 over 0 indeterminate form, okay? So that's for today, guys. I'm not going to have until 1 o'clock. So we stop right here.